so much. The first speaker is Greg Sleeper. Yeah, okay. And he will talk about the future of DNS. Okay.
Okay, cool. Thanks for inviting me to this, and packed room. Really cool. Hopefully, this will be the future of DNS, at least that's my hope. We'll see how things work out. So, my name is Greg Sleepak. You might know me from such software endeavors as espionage, or from the OK-Ternals Foundation, where we work to support beneficial decentralization technologies, and hopefully create some of our own, like DNS chain, group income, as well as specifications like group currency, and today we'll be talking about DPKI mostly. So it's important to know your audience, and this was a quote from an email I received from Ronnie, saying that most of you here are either system or network administrators or software developers. So my assumption going in is that you are familiar with things like the basics of what DNS is and how it works. I'm going to give a brief overview of the problem. I won't go into details on DNS. And just to say that the way that things work today is when a user wants to visit a website, they enter a domain name into the URL bar and hit enter. From that point, DNS is responsible for returning an IP address. And this is done completely insecurely. It's very trivial to man-in-the-middle DNS and return some totally inappropriate IP address. That IP address then, if the website is set up to support HTTPS, will return a certificate. And then the web browser will verify the authenticity of that certificate against the built-in list of certificate authorities. So this is a screenshot from my computer. There are, on this Mac, over 160 root certificate authorities installed that Safari checks, and every one of those has the power to designate others known as intermediate certificate authorities. And each one of these has the power to make this lock icon appear on your web browser. So next I'm going to show a few slides from a video on our homepage on okternals.com. This is a video on DNS chain. And one of the things that we point out is that there was somebody who ran the numbers, and across all desktop operating systems and across all web browsers, counting intermediate certificate authorities, there are about 1,200 entities who have the power to make that lock icon appear. And so how does a man-in-the-middle attack on HTTPS work? Well, the man-in-the-middle sends, as the certificate, intercepts the connection from you to the website, and sends over a certificate that they got signed illegitimately, but in the eyes of HTTPS, it might as well be legitimate. And in effect, there's basically, your browser is asking, is this legitimate? And someone in a massive crowd of people says, yeah, sure. And then your browser displays the lock icon and tells you the connection is secure. So let's try to more clearly define this problem to get a better understanding of what's going on. The basic problem is who can define your identity when you're not there. Remember, in the context of the internet, we need to be able to have online identities, whether it be for individuals or for organizations, whether it be for your handle on a social network or a website domain name. You're not there to tell random strangers who don't know you and who you don't know what your public key is, for example, what the correct information for communicating with you is. So this is a very fundamental problem that we're still struggling with. So let's say you came up with a decision as far as who's going to be trusted. In X509, that's the mechanism, the trust mechanism behind HTTPS. It's you know, the least trustworthy of over 1,200 entities is who everyone online today is trusting. And you have to ask yourself, is there a good reason to trust whoever you picked in number one? And then finally, is the mechanism that you developed actually user-friendly? Can it be used by both system administrators and users? So we're going to go over some of the previous attempts to solve this problem. And I'm probably going to run over, you know, out of time. But whatever. I'll try to go as fast as I can. So let's start with X509. Well, we're done. We just covered it. Next, moving on to DNSSEC. DNSSEC is complicated. Wikipedia says that there are over 10 RFCs for it. Thomas Patek and Aaron have this to say, that DNSSEC is expensive to deploy. Well, furthermore, DNSSEC is unnecessary. Again, from the blog post against DNSSEC, the URL is down here, and these slides are put online, so you'll be able to visit all these links, read them in more detail. And we'll go into detail on why it's unnecessary. But basically, TLS handles everything that DNSSEC does. This is Moxie Maryland Spike, same thing. DNSSEC is broken. This, there's a website, and this next slide might take a little bit to load because of just how large this JPEG is. There's this amazing website that tracks major DNSSEC outages and failures, as well as software bugs and all kinds of various different problems related to DNSSEC. And as you can see, it was updated a few days ago. So, just some of those problems. Again, that's not the end of the list. That's not the full image either. So DNSSEC is unnecessary and it's less secure than X509. And why is it less secure? Well, it's because when you look at that answer to question number one of who are you designating as your trusted entity, DNSSEC designates more entities than X509 does. Registrars, TLDs, and ICANN. So that we'll see all this on a nice table in a second. So Thomas says that DNSSEC is the world's most ambitious key escrow scheme, a backdoor that hands over control of internet cryptography to world governments. Well, thankfully, it's also very broken, so we don't have to worry about that. Okay, moving on to convergence and perspectives. Moxie Maryland Spike is responsible. His answer was convergence. Convergence is now seemingly a defunct project, but it was legitimately an improvement. Perspectives is another very similar project. So this table is taken from the Certificate Transparency website, which compared various different approaches and lists some of the problems with the various, a few different approaches. DANE, by the way, is kind of like bundled in together with DNSSEC. This table isn't entirely accurate. There are some yeses when they should be nos, but we don't have time to get into those. So this is a quote from the Convergence website. Rather than employing a traditionally hard-coded list of immutable certificate authorities, Convergence allows you to configure a dynamic set of notaries which use network perspective to validate your communication. That's a misleading statement. Why? Well, because 99.9% of users won't know what notaries are or how to select them. So in practice, this will end up being effectively the same thing. The browser would ship with the list, and users would just have to kind of go along with it. But the real improvement in convergence comes from the fact that it employs consensus. And this is a concept that I'm going to spend a lot of time trying to ram into your heads today. So what is consensus? Consensus is when a group of assumed independent entities agree on a decision, i.e., if a public key is valid, if the mapping from an identifier to a public key is valid, using some voting threshold. And voting thresholds are worthy of an entire talk on their own, If you're interested in voting at all and voting thresholds, I highly recommend checking out these slides later on and visiting these 2 links, or just going to the Group Income blog. We put a lot of time and thought into research into that topic. So another issue with convergence is that it's not effective against server-side man in the middle. That's where there's a man in the middle between the server and the rest of the world. Pinning. Pinning is a concept. How many here know what pinning is? Show of hands. Okay, about 20%. So that's unfortunate. You should be familiar with pinning, because pinning is one of the strongest defenses that the internet has against man-in-the-middle attacks. Pinning is very simple. It's a very simple concept, like trivial. Everyone here should be able to understand it instantly. The idea is that basically a priori knowledge of the key that you're expecting to have, to receive. Or another approach is called TOFU, for trust on first use. When the first time you receive a public key, you just trust it, and from then on refuse to accept any other public key. So there are 2 specifications that were written for this. The one that actually got adopted is HPKP. And HPKP is a decent specification, but the problem is that it's difficult to use. So websites can be broken for long periods of time if it's not used correctly. If the server's key is compromised, and they did not additionally pin a trusted certificate authority, then the website can be down for a very long time. Or, say it lost the key. And if the system administrator decided to say, pin the certificate authority in addition to this specific key, then they're designating that certificate authority the power to issue invalid certificates for that website. Another issue with pinning, maybe not a big one, is like the issue with trust on first use, is that it's not effective on the first time you visit the website. This is a more serious problem. Pinning is broken for users with broken system clocks because it's based on time. So if you say pin for 3 months and it's supposed to expire on this date, but your clock is all screwy, it's not going to work. So let's look at their answers to the problem. In X509, it designates government certificate authorities the ability to define your identity. And of course, as well as hackers who are able to compromise any of those entities. In addition to you. All of these are, of course, you can define your identity, but others can kind of override it. Is there any reason to trust these governments or certificate authorities? No, there's 0 reason. Most people aren't aware of who the certificate authorities are, so they have 0 reason to trust them. Is it usable? Yes, yes it is. DNS more. Governments, registrars, TLDs, we went over that. Same, no reason to trust. Convergence. Nation states would have the ability to attack convergence. So if that's part of your threat model, it's not with colluding notaries. Is there reason to trust convergence? Well, in effect, there is some reason because it gives users the potential to choose the consensus group that they trust, whereas X509 doesn't give you that option. HPKP. Who can define, if you, the system administrator, chose a certificate authority, then you are giving them the power to define your identity. If you did not, then you did a great job. Well, I mean, it's unlikely that anyone else is going to be able to override your identity, but you could break your website. So that's why we say it's not usable. So new attempts. We're going to go over a little bit certificate transparency, key transparency, conics, DPKI, and SCP, Stellar Consensus Protocol. But before we get to that, I should address a question, because the title of this talk was supposed to be about DNS chain, but here I am talking about DPKI all the time. So what happened with DNS chain? To really answer that question, it helps to kind of start from the beginning and look through the history of the project. In November 2013, I released the DNS chain paper and website as part of my senior project. at the University of Florida. So then on Christmas morning, I get a nice Christmas present I got. Somebody submitted it to Hacker News. And in February, we released the code. In May, I went and presented a demo along with that video that many of you might have seen at the EFF Crypto Usability Cup, which was a thing on like internet privacy, and it was ironic because it was hosted at Facebook. Then in June 2014, OneName posted the first blog post about using blockchains to secure online identity. So this results in an ongoing collaboration with OneName, and of course I was collaborating with Namecoin beforehand. Covered an Engadget. OneName announces funding. We release blockchain ID specification. OneName releases Blockstore. They move from Namecoin to Bitcoin. Then in February 2015, at the first Rebooting Web of Trust event in San Francisco, we write and publish the DPKI paper describing DPKI, the basic idea. And Rebooting Web of Trust, what is that? So that's a very important series of events that are going on and are continuing to go on, and I encourage you, if you are at all interested in this topic, to keep tabs on that. Hashtag Rebooting Web of Trust. It's really cool because this is a group that is producing solid material, including specifications, and it is organized by the co-author of SSL-TLS, Christopher Allen. So OneName renames themselves to Blockstack. Rebooting Web of Trust 2 happens in New York. One of the co-authors of the DPKI paper announces Uport for Ethereum, which is a very cool project. At Rebooting Web of Trust 3, I submit as a draft Slepax Triangle. Little did I know somebody had already written on this topic, so we're now calling it the DCS Triangle, using their terminology. And that is another important thing that I'll be covering today. It's, well, we'll get to it. So, with many companies now in this space exploring blockchain identity, the need for a blockchain-agnostic protocol, like DPKI, continues to grow, so that we can actually use this stuff in web browsers. So back to those new attempts. So all of the other new protocols besides Stellar are summarized in this table, and you can read the details on this by visiting that website or just going to our blog, blog.okturtles.com. What is important to note here is that certificate transparency, neither certificate transparency nor Google's key transparency, and we call it Google's because these are generic concepts that Google creates specific implementations of, provide man-in-the-middle prevention. They might be able to provide man-in-the-middle detection, after you've been compromised. Another interesting point of note is that only DPKI, because of its heavy emphasis on blockchains and their ability to issue a token, has economically backed security. There's effectively a $20+ billion bounty, bug bounty out there for Bitcoin right now, for anyone who can compromise it. And that is, gives you a monetary feel for how secure that protocol is. And censorship resistant. DPKI, because of its decentralized nature, is censorship resistant. That's important. We'll cover that soon. I don't have time to talk about that much more, though. So a quick lesson on namespaces. What is a namespace? It's a space where you can have names. So we can throw in some names into this space, like Alice, Sue.com, Bob. If we throw Bob in again, no, that doesn't work. That's a name conflict. So it's basically a key value mapping from names to data. And this poorly done slide explains why DNSSEC isn't necessary, because effectively both the DNS and X509 are operating within the same namespace. But the problem is that there's no consensus on that namespace. So DNS can return different values for an identifier. And you can issue multiple certificates for the same domain name. So we don't know what these mappings should be.
Could there be a reason for issuing?
Questions for the end, sorry. So who should decide what the mapping should be? Any guesses? Who should decide what the mapping of an identifier, like a domain name, to a public key should be? Everyone? So if you register bob.com, I should have a say in your defining your website?
Yes.
And
Maybe the majority. Maybe at least the majority.
okay, I'm just going to, sorry. Any other suggestions?
I guess the creator of the website?
Yeah. You, the person who registered the website, should be the person defining what that website is. This brings us to centralized namespaces versus decentralized namespaces. And specifically, I'm talking in the context of global namespaces, namespaces that are accessible from anywhere in the world. Centralized namespaces, who controls the mappings? Not you, unless you're running that namespace. They are incapable of providing ownership over an identifier to its users. And likewise, they're incapable of censorship resistance for the same reason. Censorship resistance is the idea that it's resistant to censorship from any one entity. Well, obviously, one entity controls the namespace, so it can censor the namespace. Decentralized namespaces, on the other hand, provide censorship resistance and because of that, ownership. So who controls the mappings? You do. That is, as long as they remain decentralized. We're going to talk about that. Call it consensus capture. And another reason to use decentralized namespaces is because the internet requires it. If you don't use a decentralized namespace for this, you are basically recreating cable television. So Zuko's triangle was a very neat sort of assertion made by Zuko Wilcox, saying that you can have at most 2 of 3 desirable properties. A naming system can either be global and secure, global and human readable, secure and human readable, but not all 3. And the DCS triangle is, I think, related to this. So Aaron Schwartz published a blog post called Squaring Zuko's Triangle, asserting that it was possible to square this triangle. And that Namecoin, well, Namecoin wasn't released at that point, it was released 3 months after the blog post. But that the blockchain could be used to do this. So moving on to DPKI. So DPKI is different, and it has to be different from everything, all the other protocols that I've talked about so far. And it's different because it is not a consensus protocol. Rather, it's a protocol for consensus protocols. And that's because it recognizes the concept of consensus capture. So what is consensus capture? Consensus capture can happen in a variety of circumstances, but the fundamental circumstance when it happens, and what I mean by that is, let's say you designed a consensus system and you did everything right. You designed a perfect consensus system. Consensus capture can still happen if you did a really great job. You'll become a victim of your own success. So here's what I'm talking about. Here's our consensus group, 4 people. And at this point in time, they're the only users of the system. So the consensus participants are 100% of the users. Now, let's say we add some users to the system. You designed a pretty nifty thing, and you're like, hey, here's my consensus system. And some people start joining the consensus, your thing to register a name or whatever. Now we've added 6 other people, so your the number of consensus participants drops to 40%. And as the number of users grows, the number of consensus participants shrinks, because consensus is slow. And it becomes even slower with a large number of participants. So this means users no longer get to participate in the consensus. And the consensus participants cease being capable of representing those relying on consensus. As more users are attracted to the system, control of the system gives whoever's controlling that system more power, so it starts attracting psychopaths, which makes the system even less representative of the users of the system. And this is called consensus capture, when the consensus no longer is capable of serving the needs of the users of the system. And it can be found in many places, not just computers, but in the real world, where consensus happens in state legislatures. So this brings us to the DCS triangle. The DCS triangle is so named by Trent McConaughey, who published a blog post. I had no idea he had done this, and 6 days later tweeted the same exact concept. And then for the Rebooting Web of Trust, I submitted this draft, which described it and tried to prove it a very narrow interpretation of the triangle in a mathematical way. I haven't finished it, I haven't finished the proof because I haven't had time, but it should be kind of clear. What the paper did actually do, which is useful, is it gave some actual mathy definitions for these terms, specifically decentralization. It gave this very handy definition of decentralization, saying that a system is considered decentralized if it satisfies these 2 properties, which is that the number of doors to compromise the system is at least 2. So what I mean by that is there can be any component, any aspect of the system whatsoever. If there's a single component that breaks or can be broken, that system is considered decentralized. In other words, there is a single point of failure. If a system has such a single point of failure, that's what it means for the system to be centralized. Obviously, a system controlled by a company, fully controlled by a company, is centralized because most companies have CEOs who can just say, well, we're going to change the intended behavior of the system, and that is considered a compromise. So the second definition relates to who decides what the actual intended behavior of the system is. What if you want to change it? What if you liked what it was doing before, but then you got a whole bunch more users and now you need to change something? Bitcoin, block size, is a wonderful example. And this triangle can be very helpful for addressing those kinds of debates. Well, then, I came up with this idea, which I think is, not completely thought out yet, but that the redefinition threshold of the system, how many, and then that's the question, is how many what? How many users? Well, how do you count them? It's really difficult to count those users. There's a thing called the Sybil attack. And when the user becomes, when the system becomes very popular, there are centralization pressures, and so what are you counting at that point? Like the 3 big miners, for example? Oh, well, that's not really a fair vote. It's not representative at all of consensus. So very, very interesting question that we do not have time to get into. So DPKI does not specify consensus. It's a protocol for consensus protocols, and it assumes, or rather says, that protocols that participate in DPKI have to be secure consensus-based namespaces. Now, DPKI in 2 parts. So here's an example. How do you specify which consensus system you're using? You can use a TLD. So .eth would point the user to using some kind of lookup method, like a thin client, to the Ethereum network. .bit would similarly say you would need to use whatever Namecoin has to connect to the network. And there's this other question of, well, how to use a mobile device which can't run a full node? Well, okay, you need a thin client, or you need at least 2 independent nodes to check for it to be considered decentralized. So that's sort of the first step there, is how do you get into the network to like actually communicate with it in a way that gives you reasonable security and assurance that you're not being man in the middle. Then the second trust assumption is the actual consensus network itself, and that refers to like proof of work, proof of stake, and how well designed is that consensus? Can it be gained? Who is actually responsible for securing the network? Right now, it's like one dude in China. We're talking about Bitcoin. Okay. So part two, the second aspect of DPKI doesn't have to do with namespaces. It has to do with the life cycle of identifiers within those namespaces and the public keys that are associated with them. So like, what do you do if you lose your phone or you lose a key and need to recover it? How do you recover from that situation in a decentralized way? The way that we recover from that today is we usually have a password reset link, which relies on a centralized party, or you phone in and you like provide them with all of your identity credentials and you can try to convince them to reset your password. A lot of people actually end up getting compromised by those mechanisms. So what DPKI says, and the original paper suggests secret sharing. Later on, I decided that wasn't the best way to do it. There's a far simpler approach. You can just do N of N signatures. So you can designate people that you trust. And this is always important. You go back to the user. You don't say, hey, we're going to have this trusted third party. Well, okay, you can have a trusted third party, but who's deciding that on behalf of users? Is somebody other than the user? Well, then you're probably designing a bad system. Let's let the user make that decision. So the user can say, okay, I have a family that I trust. I have friends that I trust. Let's say I'm going to designate 5 delegates out of these, and if any 3 of them get together, they can override my identity. That seems reasonably secure to me. And that actually gives you a reason to trust. You actually have, they're your friends for a reason. They're your family, and if you chose your family, you must like them to be able to redefine your identity. And most importantly, you know their names. So that's awesome. Okay. Moving on, though, to Stellar Consensus Protocol. So I said I would cover Stellar Consensus Protocol, and I was running out of time, so the slides are kind of like jumbled at this point. There's some understandable confusion about the Stellar Consensus Protocol, and I'm covering it today because there's this thing called the Internet Level Consensus Group at the IATF that was recently launched that just freaked me out. Because they're considering using Stellar for like the entire internet, and that's a horrible idea. It's horrible to use any one system for the entire internet, is my point, for the reasons stated in the previous slides. So one of the reasons I think that there is confusion is because Stellar put out a bunch of marketing that has statements like this. They have this like, oh, easy to understand cartoon about Stellar. No, it's like easy to misunderstand Stellar from this cartoon. So what does this say? It says, it's not up to us. You should be able to plug right into their consensus system. Well, that's right, no need to ask permission. They're basically saying, well, anyone can participate in the consensus. No, anyone can listen to the consensus. You can't participate in the consensus. Participate means being able to have a voice, to actually impact the outcome of the consensus. Sure, anyone can listen to the deciders making their decisions, but in order to participate in the consensus in Stellar, and any Stellar-like system, those existing people have to choose you. They have to throw a line in your direction and say, okay, we are accepting this other node as being part of our consensus. So it's not true that it's permissionless. In fact, it does require permission to participate in the consensus. And Stellar has other problems, like its inability to resolve forks, which makes it increasingly likely that there will be a cartel controlling the entire system. So please don't break the internet. This is an email that I actually sent to the list. A genuine concern is the purpose of this group to create an internet cartel. That email received no replies. So this is why DPKI explicitly allows arbitrary consensus protocols. It has to. It has no choice in the matter. So even if you want to make your own DPKI thing, you still have to do this. So let's look at the answers to the new solutions to the problem. In certificate transparency, who can define your identity? Because it doesn't actually prevent man-in-the-middle attacks, only detects them after the fact. Then you have to wonder, well, if they detect a man-in-the-middle attack, but it was being used to combat terrorism of some kind, or a terrorist suspect, or whatever, or evil pirate person, I mean, are they going to do anything about that? No. Unanswered question, not specified in the RFC. So is there a reason to trust certificate transparency? I would say very low. Key transparency is even worse because it allows the server to override and insert keys without any permission from you. And this is a little known fact about key transparency because people, Google said it was based on or inspired by Connix or based on Connix. But in fact, the two systems are very different. Connix is actually a good system. And it's good because it's tofu-based. Whereas key transparency is not. So I think we've kind of covered all this. DPKI. Who can define your identity in DPKI? So as I mentioned, the people that you chose to delegate to. And it depends on the consensus namespace that you chose to identify, to register your identity in. So if you chose some Ethereum namespace, well, it depends on the rules of that namespace. And it also depends on the security of Ethereum and things like that. So DPKI gives you a reason to have faith in that lock, an actual reason. Only decentralized namespaces are allowed. Identity is controlled by you. The specification requires decentralization at every point to minimize trust, including at lookup. The spec requires that private keys never be generated or stored on a server. They have to be generated client-side, and they should never leave that client device. So if you're designing messengers and things like that, please don't ever let a private key go over the network. Only send public keys over the network. And it gives you your choice of consensus system. Potentially DPKI-friendly protocols and implementations. There are already some being worked on, things that could fit into it. We just kind of need a protocol, some kind of a protocol for this to work in web browsers without requiring, a web browser per one of these, per Bitcoin, per Ethereum, per whatever. So the EIP Ethereum Improvement Proposal 137 is the Ethereum domain name service. We looked that up. Blockstack is sort of the Bitcoin answer to this question. Uport is the Ethereum answer to the question of individual identities, not websites. If you are aware of any others, feel free to let me know during the Q&A. How can you contribute to DPKI? Well, first you should read the DPKI paper. And also two issues in this GitHub thing. Attend the Rebooting Web of Trust seminars and design workshops and all that. You don't need to ask permission to contribute. It's permissionless. Feel free to pick up where we left off. Be friendly, ask questions, and wow, I actually made it in time. Thank you. Any questions? Okay, go ahead.
This sounds like a very good system, but knowing most end users, they either use Windows, Mac, or Android, which means and they just want those things to work. So they'll basically trust whatever Microsoft, Apple, or Google say they should trust. And then you're back to square one. Or do you have a solution to that?
Okay, so the question, if I understood it, just for I guess the online audience, is Microsoft, Google, and Apple design operating systems and devices, and They are the ones who kind of decide on behalf of users who the user should be trusting. So is there anything that can be done about that? Did I get that right? Okay. Well, yeah, something can be done about that. First of all, there are always, so far we don't live in a communist state, so far there is a free market, and there are lots of people who are eager and excited to compete with these companies, especially on the security front. One of the biggest fears that today's users have about computers is that they're so insecure, and they're absolutely right. Like, the internet is a nightmare when it comes to security, especially for the average user. I'm scared, for a lot of my friends and family. In many ways, I think Apple made the right decision to kind of start moving people to a more closed-off environment with iOS, where they can't do things, just because if you can't really address the problem, you can at least remove ways of punching yourself in the face. So there is a lot of opportunity here to compete with these companies if they decide not to do this on their own. And as I mentioned, Microsoft is one of those companies, a big company, and they are exploring this. Microsoft is attending the Rebooting Web of Trust workshops, and they are exploring blockchain technologies. And I guess my answer is that people like security, people want security and privacy. There's this meme of sorts that is completely untrue, that users don't care about privacy. It's more like users don't have really a choice right now. They very much care about privacy. Give them something that's just as user-friendly, but also private, and they'll go for it.
So that means that the end users will end up trusting whoever Microsoft or Apple tells them to trust.
Well, they have a choice. They will see an option, a product, an offering out there, and oftentimes, it doesn't, Microsoft can't prevent you from using Uport, right? Microsoft can't prevent you from using Blockstack or an application that uses Blockstack, and I don't think that Microsoft wants to. Similarly, Apple, they do really kind of guard their App Store, but I don't think that they're going to prevent these apps either. And if they were to, they would lose a competitive edge, and they would just slowly start to be marginalized, and people would start abandoning their platform. It's not good business for them to block this. It's good business, and just generally smart to have a secure internet. We all want a secure internet. All right. Any other questions?
No questions? Okay, then. Thank you.